Number Theory, Section 4, Diophantine Equations. Video 1, Introducing Diophantine Equations. A Diophantine equation is an equation where you are only interested in integer solutions. This is often restricted further to simply looking at positive integer solutions. Diophantine equations are named after Diophantus, who was an ancient Greek mathematician who studied such equations. Let's look at an example of a Diophantine equation. 3x plus 2y equals 11. Find the positive integer solutions. Now, because the numbers involved here are quite small, we can solve this by inspection. So I might start with x equals 1 and say that 3 times 1 is 3. I need to then add on 2 times 4 to get 11. So that tells me that the solution x equals 1, y equals 4 is a solution to this equation. Now, if I were to try the value x equals 2, I would get 3 times 2 is 6 plus 2y equals 11. Y wouldn't be able to be a whole number there. So there isn't a solution when x equals 2. When x equals 3, I have 3 times 3 is 9 plus 2 times 1, which gives me 11. So x equals 3, y equals 1 is a solution. And if I increased x any more, I would end up, if I try x equals 4, I get 3 4s are 12. So I've gone over 11, so I can't have a positive integer solution. Let's have a look at how we might write a program to solve equations such as this. I'm going to start by defining a function, which I'm going to call dio, short for Diophantine, and I'm going to give it 3 inputs, a, b, and n. So in the example we just looked at, we had 3x plus 2y equals 11. So a is 3, b is 2, and n is 11. So what my function needs to do is it needs to check values to find solutions where ax plus by equals n. So let's start by looking at I in the range from 1 up to n plus 1, and for j also in the range from 1 up to n plus 1. Now notice that we've gone from 1 in both of these. There have been some examples in previous sections where our program has gone with I from 1 to n, but then from j only from I up to n. And we did that when we had situations that were symmetric in I and j, so that we wouldn't find the same solution twice. In this case though, because a and b are different, our equation isn't symmetric, so that means that our solutions are not going to swap around, so we need to look from 1 to n plus 1 in both cases. Okay, so for those I and j, what is it that we're looking for? Well, if I times a plus j times b is equal to n, then that means it's a solution to our Diophantine equation, so we want it to print I and j. Let's have a look with the example we tried before. So my Diophantine equation, which was 3x plus 2y equals 11, had solutions x equals 1, y equals 4, and x equals 3, y equals 1. There's that function again for you to see. So notice we started by defining the function which took a, b, and n. We looked in the range of 1 to n for I and 1 to n for j, because this isn't symmetrical, so we need to start from 1 in both cases. And then we just looked exhaustively for anything that satisfied this relationship, which would be a solution to the equation, and then told the program to print that out. And there are our 2 solutions, which we found on the previous slide. In this video, you've learned the definition of a Diophantine equation, and you've learned how to use Python to solve simple Diophantine equations.